Hey Evie, how are you? Why? Why are you terrible? But I'm doing well, thank you. Okay, done with that. That's fantastic. Oh, okay. Hey Lila, I'm good, thank you. How are you? You saw all your maths papers. Why was that so bad? Should be fine, no? I mean, it's a very good score, but I get why you aren't happy with it. Like, I know you were aiming for a lot higher, but 78 out of 80 is not bad. Like, that's strong. But yeah, I think you'll get it fine. You'll do more than fine. That's what happens. Silly mistakes. I was 4 away from a 9. It's silly mistakes again. Yeah, always is. It's still really impressive. Okay. For today, I think pretty much everyone's joined that's going to join. Yeah. For today, we're going to basically cover all of stats, which is basically all of the paper 3 stuff. Okay, so it should be very productive. So yeah, we're going to cover all of stats, all of kind of the paper 3 stuff that you need to do. Okay. Hello, ice cream. How are you? So yeah, we'll get started. So with paper 3, essentially how it's broken down is the majority of it is stats. So things like pie charts, histograms, bar charts, scatter graphs, working out the mean, median, and mode from group data and all this fun stuff. And there's also stuff that they couldn't fit into paper 1 and 2. So it's a bit of a weird crisscross mismatch of topics. But so what I figured out I'll do is I'll go through and find like a ridiculous number of questions, probably an offensive number of questions, and we'll just kind of go through it just to cover as much as possible. And what you should do is, if anything I say is you're unsure of, let me know and we'll go through it. But also, you'll be able to target your revision a bit better. Paper 3 tends to be something that's neglected in schools. So for this question, it's a histogram question, shockingly. And it summarised the time spent by 1,000 visitors at a flower show. So it gives us the frequency, density, and the time spent. So first of all, what is a histogram? Well, a histogram looks a lot like a bar chart, but it's not a bar chart because A, all of the bars are touching each other, as you can see. And it also has this thing called frequency density. So the way you get frequency density is you take your frequency, so that's just the number of people or things, and you divide it by something called your class width. So this is the other part of a histogram. The class width is just this thing here. So it's the width of each bar. Okay, so each bar is a class width. So 2 and 4 is one of the class widths. The width of that class is 2 because there's a difference of 2. Okay. This is calculate the percentage of visitors who spent 6 or more hours at the flower show. So if we look at 6 or more hours, that's everything from this to the right. So we need to work out how many people are in each of these 2 bars. Okay. Now, the number of people is just the frequency. So all we're doing to work that out is we're getting the frequency density. So I'm going to call it frec dense. And we're timesing it by the width of each bar. Okay. So if I have a look at this one here, the frequency density, well, first of all, we need to work out what the actual boxes go up in. Is this big enough, by the way? If you want me to zoom in a bit more, I can. Apologies for the quality. Some of the other quality is a lot better, but for some of these questions, they're quite old papers, so it's a bit difficult. Okay, cool. So we have 1, 2, 3, 4, 5, 6, 7, 8. Cool. So we have 10 bars. Sorry, 10 squares in between 100 and 150. So each small box is equal to 5. So if we look here, it's 2 boxes below 150. So that frequency density here is 140. So 140. So the frequency there is just going to be 140, the frequency density. And what's the width of the bar? Well, it goes 6 something and then 8. So that something must obviously be 7. So the width of that bar is just 1, because it's the difference between 6 and 7. So we times that by 1. So there's 140 people in that bar there. Again, stop me the second it doesn't make any sense. With this next bar, what's the frequency density? Well, let's read it off. So again, each small square is 5. So we have 50, we have 45, 40, 35. Absolutely, Evie, I can. So that's 35 times. And if you look at the width of this bar, it goes from 7 to 10. So that's a width of 3. Okay? And that would be 105. So again, for those of you that are in the chat, just make sure you ask any questions if you're a bit stuck. Okay? Because it is a bit of a tricky thing. Again, the best way for me to teach you paper 3 stuff is just to start going through it instead of teaching it individually, because I think it would be a bit too boring. So now the total number of people that are above 6 hours is 105 plus 140, which is 245 people. Now it's actually asking me for the percentage of visitors that spent 6 or more hours. So as Evie just said, there's 1,000 people in total, and there's 245 people above 6 hours. So we're going to do 245 divided by 1,000. But then to turn it into a percentage, we're timesing by 100. So it's 0.245 times 100. So 24.5%. 3 marks, not too bad. Keep in mind that once you get a bit better at this, or maybe you are already good at it, I don't know, you'll be able to kind of do this much quicker than the way I'm doing it. I'm taking it very slow for you guys. Okay. So Evie says it's fine. Anyone else? Is everyone else okay with that? Hope so. Perfect. So jumping on to a completely different topic for stats, we have... Yeah, could you show me how to do a question where, for example, you need to work out 20% of it? Absolutely, yeah. That will come up a bit later. But if not, then we'll find one for that, definitely. So if you were to work out 20% of it, what you would have to do is find 20% of the total number and then work out which bar that would be in. So you just go from left to right. But we will do one at the end. Exactly. But we'll do one at the end because that's a very good question. It could be the opposite. Okay, Lila says good, perfect. So in this case, we've got a scatter diagram. So what is a scatter diagram? Well, all you have is you have an X and Y axis that have kind of continuous data on them. And you just plot little X's, okay? Nice and easy. However, the first question here says draw a line of best fit. That's the only additional thing for a scatter diagram. And what we're going to do is, I'm going to try and draw it with a line, but the problem is it doesn't work that well. But again, you'd use a ruler for this. Drawing a line of best fit, what are the important things? Well, it doesn't have to go through the origin. That's a mistake I see some students make, is they'll draw a line from the origin and try and get through as many points as possible. All you need to do is draw a line that goes through as many points as possible. And it should start in line with this first cross and end in line with this last cross. So you don't want something that goes all the way across, right? You need to end in line with this. Start in line with this and end in line with this, okay? So, the objective is to go through as many points as possible, but one rule of thumb I like to use is that the number of points above the line should be equal to the number of points below the line. That's a good rule of thumb. So literally get your ruler, if it's a see-through plastic one, that's even better, and try and make it so there's an even number of points above and below the line. It's going to be a bit difficult for me to show this, but let's... So we have 1, 2, 3, 4, 5, 6, and there's 4 below. So okay, I've made that. Need to make it slightly steeper. Again, if you have a ruler, it's a lot easier, shockingly. And that might be a bit better. But again, technically speaking, it should end slightly before that. About there. If they gave me tracing paper with stuff drawn in it, should they give me... They should give you a clean one, yeah. In your actual exam, you can ask for a clean piece of paper because otherwise it's a bit confusing, a bit hard to use. Okay. So hopefully line of best fit is fairly okay. You have to draw them in science too. So it's probably a skill you've got a bit of practice with. And for part B, it says estimate the mass of a West Highland Terrier that has a height of 26.7. So what they're going to do is they're going to give you like either a height or a mass, right? They'll give you either an X or a Y value, and you need to find the opposite value. So in this case, they're giving me an X value, and I need to find the Y value. So to do that, all I need to do is... Actually, you probably can't see that just yet. So, okay. All you need to do is find where 26.7 is on this axis, and go up, touch the line, and go across. So there's 1, 2, 3, 4, 5 in between. That's a bit wonky. So it'll probably be 0.2, 6, 0.7, 0.8, 0.9. Yeah, so it goes up in 0.1s. So 26, 20, and 26.7. So it starts from this little part here. And I'm going to draw a dotted line going all the way up. And the second I hit my line, I'm going to draw a line going to the left. And I'm going to read it off. Okay, so it goes up in 0.2, so 0.2468. So that would be 7.9 kilograms, right? Now, just so you know, for the actual answer, they give you a range. You can get anywhere between 7.5 and 8 kilograms and still get the mark, okay? So they give you a bit of wiggle room. Okay, you don't have to be super exact, but again, use a ruler, dotted line all the way up to your line of best fit, ruler, dotted line across. I'm not using a ruler at this point because, you know, kind of hard to use one. With the graphics tablet I have at the moment, but yeah, hopefully that makes sense. Okay. This is part C. Another dog has a mass of 8.2 kilograms and a height of 35 centimeters. Is this dog likely to be a West Highland Terrier? Explain your answer. So if I have a look at this, if I go to my thing here, so mass 8.2 kilograms, well, that's on the line, right? That's on the actual graph. But if I look, 35 centimeters isn't even on my axes, right? So what that tells me is that at least for all of these dogs, it's well above what all the rest of the dogs are. So what I'm going to do is I'm going to tick the box no, and the reason for that is that the height of 35 centimeters is very far or much higher than from our data points. Okay? Right? So it's like if I talked about a person, right? You know, average person's about 5'9" if they're a man, and I said, okay, there's this thing that's 8 feet tall. Is it likely to be a human? Well, no, because it's well above the range that we would have for a normal set of humans. Okay? Any questions about that? Yeah, and it was 3 marks, nice and snappy, nice and quick. But this is the kind of thing you can expect from a scatter graph. So you're going to draw a line of best fit. Okay, so essentially you're going to get a scatter graph in your paper 3, 100%. Guaranteed. One of the questions will be drawing a line of best fit. Another question will definitely be estimating a value. So they'll give you either the X value or the Y value, you need to find the other. Those 2 parts are guaranteed. The third part, it can be a bit of a curveball. They will probably say something along the lines of this. Right? Perfect, okay. So, next one. We get another scatter graph. So the Shorts Hut is a shop that sells sports clothing and has a customer cafe. Cool. The manager plots some sales data in a scatter graph. Yeah, absolutely. Like, scatter graphs come up every single year in paper 3. It's one of the core things that they need to test. It's like how Pythagoras will always come up every year. That's shocking. It might be because they haven't... it might not have been an actual paper 3. What it may have been is that they haven't taught you the paper 3 stuff yet. So they haven't, like... You know, there weren't enough questions to do it. They may have edited the paper slightly. Yeah. The manager plots some sales data in a scatter graph. Yeah, the practice ones are slightly different, so they would have been changed. It's like the practice one we found last week, Evie. The graph shows the number of hot drinks sold and the number of ski hats sold. Okay. So, hot drinks, ski hats. The manager says this graph shows that an increase in the sale of hot drinks causes an increase in the sale of ski hats because the correlation is positive. Explain why he's incorrect. So they're lucky that they've told us it's incorrect. Okay? Because if they didn't tell us it was incorrect, I'm willing to bet quite a few people would say, okay, well, it's positive correlation, therefore, an increase in the number of hot drinks sold increases the number of ski hats. So why is he incorrect in this case? So one key thing, and it's literally on your spec, is that they say this. They'll say correlation does not imply, and this is probably the most important thing you can take away from GCSE stats, right? The stats part of maths. Does not imply causation. Because this comes up a lot in life. So whenever you look at the news and stuff, and they use this. So what this means is that just because these two data points correlate, it doesn't mean that one's causing the other. Let's think about this logically, right? Does it make sense that selling more hot drinks causes more ski hats to be sold? No. What does make sense? Well, it makes sense that more people buy hot drinks when it's cold and more people buy ski hats when it's cold. Right? So it's not exactly. So it's not the hot drinks causing the ski hats to be sold. It's the weather, the cold weather. That makes more sense. Okay? Yeah, perfect. You will do it in science. But this is such an important thing in real life. Because the media throw out lots of statistics and they'll say, therefore, this means this. No good mathematician or scientist will tell you that just because data correlates means that it is actually true. Okay, you can get statistics to tell you whatever you want, right? So this is actually a really good question, but this is literally a spec point. Correlation does not imply causation. So that's all you need to write, okay? If you want to add a bit more, you can say it makes no sense that hot drinks correlates with ski hats being sold, right? You could also say, like, after this, you need to say this sentence, but then you'd say, like, the cold weather is the likely cause. So yeah, always apply logic to statistics, okay? And that's just real life advice, so don't need to worry about it. But that is just a spec point, and look, it's the only part of the question. Then part B, the manager plots another scatter graph showing the temperature and the number of hot drinks. Now this makes a lot more sense, doesn't it? Right? So the number of hot drinks, as you can see, it's decreasing as the temperature increases. Again, that's fairly self-explanatory. And look, it's the same two questions I said would come up every time. Draw a line of best fit and then work out the number of hot drinks sold when the temperature is 6 degrees. Cool. So, draw a line of best fit. Again, you want to get your ruler and you want to go through as many points as possible, okay? So, okay, this is going to be a bit tricky for me. Again, you'd want to use like a see-through ruler. If you don't have a see-through ruler, I'd recommend getting one because it'll make your life a bit easier. So there's 1, 2, 3, 4, 5. 1, 2, 3. Okay. I'd say that's not bad. Not great, but again, go easy on me. I don't have an exact thing. It's not a straight line either, right? So that's a bit of a problem. What I could do... So the straight line tool on this really sucks. So I'm going to draw like a slightly better one. Yeah. See, I would say satisfactory, but I'm a bit of a perfectionist, so... By the way, this is why I don't use a ruler in my lessons, just so you're aware, because there's 1, 2, 3, 4, 5. It's a bit too steep. I'd say that's probably a bit better. I'm going to leave that to the side for now. Again, something similar to that, right? You have a bit of leeway in it. But you get the mark for that. And it says, estimate the number of hot drinks the cafe will sell when the temperature is 6 degrees. So again, you're finding 6 on here. So what I'd recommend you do is work out what it's going up in. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 between 0 and 5. So each small box is half a degree. This is going up in 0.5s, right? If you're unsure of how I managed to do that, let me know. So 5.5, 6. So 6 is right here. So should I use the ruler for this? Actually, no, I can draw a straight line like this. It's fine. And then read it across. So I can see it's going to be this point here. So that is, how much does it go up in? Well, there's 1, 2, 3, 4, 5 between 30 and 40. So each one is 2. So that should be 32 hot drinks sold. So just for you guys to be aware, the actual range was 28 to 33. So my line of best fit wasn't perfect, but not too bad, I'd say. But of course I'd say that because it's me doing it. Okay. So, comment on how suitable the graph is for estimating the number of hot drinks sold when the temperature is more than 17 degrees. Give a reason. So again, this is something that... these are very stereotypical questions for scatter graphs. So if you notice, they will give you a number that is not on your range, right? If you have a look, our graph ends really at whatever this value is. I think that's about 7 degrees. So you can't use it, or it's not good to use it to measure something that's all the way over here, right? And the reason for that is it would be extrapolation, okay? So you'd say not suitable, exactly, you can't tell. So there's a few different things you could say. Is if I continued my line, can you see it would actually be below the x-axis? So it would be a negative number of drinks. Does it make sense that you'd sell negative numbers of drinks? What does that mean? People gave you them instead? That doesn't make any sense. So you could say, like, there's a bunch of different answers. So what I'll do is I'll read out a bunch of different answers that you can have. But what I would use is it is outside the data range. Or the data given. Okay? Exactly. Free drinks, I guess, right? This statement here, the reason why I like it so much is because A, it's true, right? But B, you can use it whenever it's outside the numbers, right? So you can literally rewrite this sentence for any one of these questions and you'll get marks. Right? You don't need to think of anything else. So that's why I like it, because I'm lazy. If I can just remember this one thing, boom, 1 mark free every single time. However, some other things you could have said is it gives a negative number of drinks if you continued the line. You could say there isn't much data, so it's not very accurate. Can't be sure of the pattern. Other things might influence it. Or it's outside the data range, right? So any sensible suggestion. I hope that makes sense. Actually, it's just 10 days, right? Yeah. Interesting. Okay. Perfect. Okay. Now we get onto box plots. Box plots really aren't too bad, but the thing is, again, your school may have only breezed over them, or they may not have done them at all. So it's completely understandable that you might not know how to do it. They actually give us a lot of the information here, so we're quite lucky. But a box plot, all you need to do is you plot the lowest value, the biggest value, and then also the median, upper quartile, and lower quartile. Good. I'm glad to hear that, Evie, okay? That's all you need to plot. So the 4 things you need are the big value, the small value, the biggest and smallest values. Then you just need the 3 quartiles, so the median, the upper quartile, and you need the lower quartile. But if you have a look, it just gives me the interquartile range. But if you remember, the interquartile range, IQR, is just the upper quartile minus the lower quartile. So to work out the lower quartile, you can just rearrange that to Q3 minus the interquartile range. Right? So 4.5 minus 2. So our lower quartile is just 2.5. Can you let me know if the notation or if the algebra was a bit quick? If so, I can quickly do it. It's not too bad. I had this in my mock and completely forgot how to do the interquartile range for 5 minutes, then realised. Yeah, it's always the small things that get you in exams. But again, so let me know if this is okay. If not, I can go through it a bit more detail. But for now, I'm going to start plotting. So 1.5 is your minimum value. So These are called the whiskers, so you're going to draw fairly long lines. The maximum is 5, so I'm going to draw that now as well. And I like to keep them in line if I can. And by that I mean the same length. Now, technically speaking, these lines on the side should be longer than the ones you put in the middle, right? That's a bit of a technicality. You don't need to do it, but I like to do it because it looks nicer. That's my lower quartile, 2.5. Median of 4. So let's put that there. And the upper quartile of 4.5 there. So then it's a... Oh, God. All right. My old man hands are very shaky, so... Yeah. A ruler and a pencil would look a lot better than that. That's all you need. And you get 3 marks. You've just plotted it. It's not really that bad. So you get marks for the shape and marks for the finding the lower quartile, and then marks for actually like plotting it correctly, okay? By the shape, I mean you have these whiskers and you have like a box in the middle. 1 out of 3. Thank you. I appreciate it. Yeah. Okay. Hope that's okay so far. So here's a box plot of Ellie's data. So it's the same thing in terms of... So just to read the situation, because it's quite important. Each day they record how many hours they spent playing video games. Teddy does 30 days, and this is his data. This is how many hours he spends. And this is Ellie's for the same 30 days. Okay. Now, actually, my bad. I shouldn't have said that, because it says, is it possible to tell from the box plot the exact number of days for which Ellie recorded her times? No. Okay. So I assume that they did, but it turns out that was the exact wrong part of the question. So if you look, none of these values here tell me how many pieces of data I have, right? So I have no idea. I mean, how can I tell how many days she recorded it for? It doesn't, right? So what I would say here is box plots do not show individual data points. So the reason why box plots are so useful is you can use them for big data sets. If you, let's say you had like 500 pieces of data, right? You can't really use like a scatter graph because it'd be huge, right? It'd be enormous, 500 pieces of data, and it would be very blurry and you wouldn't see much. So these tend to be used for big, like a large number of data. So in this case, 30 pieces of data. It's quite a lot. And it also shows you things like the averages, so it can make it easy to compare data. Okay? But it doesn't actually tell you how many individual data points. Okay? Right. Hope that's okay. We're getting through this very quickly, which I like. Next. So again, we have 24 questions to do. So let's see how much we get at. So the tourist office in Truffenberg displays the snowfall data each month in a table. The table shows snowfall in Truffenberg for each day during January. And it gives us this. So this is called grouped continuous data. Okay? It's grouped because we have these things. Great pronunciation. Thank you. I have no idea if it's correct, to be honest. It just looks German to me, so I assumed it's a German thing. So you put it in these groups. It's continuous, because continuous data is something that isn't really explained very well. It means it can take any numerical value, right? So things like height, for example, are continuous. In this case, it's the depth of snowfall. But things that aren't continuous could be shoe size, right? Shoe sizes tend to be like size 1, 1.5, 2, 2.5, 3. You don't really see like size 1.785 feet, right? It tends to be fixed numbers, and that's called discrete data, okay? So continuous data can take any value. Your height could technically take any value, right? You could record it to the nearest millimeter or even micrometer or something if you're insane. You can go really, really deep. But with things like shoe sizes, it's discrete because it has set values. Technically, money is actually set values, right? It's actually discrete because you have a smallest unit of currency, 1 penny. Hopefully that makes sense. So is everyone okay with the difference between continuous and discrete data? If not, I can give you a few more examples. And it's data because, you know, it's numbers, right? Information, that's what data is. Perfect. Yep, good. Wonderful. So we need to calculate an estimate for the mean. So the mean, in general, you add up all of the data and divide it by the number of pieces of data that you have. So for example, if I had like 3, 5, and 8, the mean would just be 3 plus 5 plus 8 over 3. So 3 plus 5 is 8, plus 8 is 16, so 16 over 3, and that would be your mean. The thing is, when we have grouped data, like we do here, there gets to be a bit of a problem. It's grouped. I don't have the individual pieces of data, so what do? What I do is I take the midpoint, okay? Perfect. So the midpoint of each of these would be 10, 30, 50, 70, and 90. Now, that's because it's grouped data, right? Another problem is that I'm not just going to, like, how do I work this out now? Do I add up all of these and divide them by the number? Do I add up all of these and divide it by the number? You kind of do both. There is one day that had, in this case, 10 centimeters of snow, 8 days that have 30, and so on. So what you do is you multiply it. So what we're going to do is we're going to do 10. So we take the midpoint and we times by the frequency. In this case, the frequency is the number of days. Okay? So it's always this column, you find the midpoint times by this column and add it all up. Okay? I'm glad. Hopefully you got full marks with that. Thankfully, this is almost always on a calculator paper. And when I say almost always, there was a really annoying GCSE question. We had to work out the mean of grouped data by hand, which is not fun. It's long, it's not difficult. And then you divide it. Okay. So by the number of data. So how do you work out the number of pieces of data? You calculate. Come on. Okay. You need to get a new calculator if that's the case. To work out the total number of data, all you do is you add up the frequency column. Okay, I'm going to write it out fully this time just to make it super clear. But normally they actually tell you, yeah, perfect. Normally they actually tell you. So in this case, it says each day in January. There's 31 days in January, so you could just divide by 31. But honestly, I would calculate it just because I'm really worried that I'd get the number of days wrong. So let's enter this in. So this is probably the longest part, is actually, you know, entering into the damn calculator. That's 8. Oh god. I'm doing this on a keyboard, so I'm being a lot slower than I normally would, I promise. I'm not geriatric yet. If any of you see me make a mistake, please point it out, because I won't know. Yeah, honestly, me too, Lila. I know there's a little like rhyme you can do, but you know, screw that, man. I've got more important things to worry about. And it'll give you, normally it gives you quite a long decimal, so I'll just do it to 3 significant figures, so 55.8 centimeters. Okay. Now what I want you to do as well is have a think about whether or not this makes sense, right? So if I look at all of this, I can kind of see the middle should be around this class because it's kind of even both sides. Iteration PTSD, yeah. Yeah, 4 marks. Like, that is not bad. That's as much as the entire scatter graph question that we did earlier. In fact, it's kind of more in some cases. Because it's the modal class, yeah. So it kind of makes sense. Don't rely on that, though, because keep in mind it could be skewed one way or the other. Yeah. And if you do A-level maths, by the way, you're going to come back to doing the mean and like weighted means and all that fun stuff too. Okay. Hopefully that's all good. I had a 6 mark on my chem, which was working out the gradient of a line. Wow, that's chemistry, man. They really rely on you having no math skills. Okay, so there were 9 days when the snowfall was between 40 and 60 centimetres. On each of those days, the snowfall was actually between 57 and 59 centimetres. Okay. Interesting. Right? So if you have a look, before it was 40 and 60 was 9. In actuality, it was between 57 and 59. So what this question tends to be, by the way, the part B, is it tends to be, why is your mean an estimate? So let's ignore part B for now. I want to make up my own part B. Normally it says, why is your mean an estimate? The reason for that is because we take the midpoints, right? If you think about it, in this class here, 0 to 20 centimetres, I'm assuming this one day had 10 centimetres of snow. Exactly. In actuality, it could have been 20, it could have been 19, it could have been 1, it could have been 0. Same here. I'm assuming all 8 days are roughly 30 centimetres, but they could have all been 20 or all been 39, right? They've kind of switched up the formula here, and they've made it that, in this case, it's actually between 57 and 59. Explain why the estimate is actually fairly accurate. So the reason why it's fairly accurate is because if you notice, it's still around our mean, right? So it wouldn't change by much anyway. Yeah? So 57 and 59 is very close to 55.8. So it actually wouldn't impact us that much at all. Okay? So all you'd say here is, would not impact much because it's close to the mean. So the data values are close to the mean. Whoops. Therefore, won't impact it much. We'd be worried if these values were like twice as big or something. But in this case, they're very close anyway, so they wouldn't really change it by much. That's fine. Any questions so far? Okay. Perfection. Hopefully this is useful. Oh, there's a 6 marker. Okay. Now it's going to be fun. So yeah, I'm hoping this is useful as like a overview and recap. If there's anything you want to go through a bit more, then let me know. Okay. A number of girls and boys with part-time jobs answered an online survey. One of the questions asked how long they each spent working last Friday. Histograms of these results are shown on the opposite page. So here's the histograms, okay? Calculate an estimate for the number of girls who worked 45 minutes or less. Okay? So, 45 minutes or less. Let's try and remember that. So we've got girls, 45 minutes or less. And this is where things get a bit interesting. Okay? 45 is actually partway through one of the bars. Okay? It's actually not as interesting as you might think. But, you know, it's somewhat different. Once again, hopefully you'll remember, is all we need to do is work out the frequency of each of these bars. And in this case, we've actually split the bar in half, okay? So if we work out this one first, the class width, it goes from 20 to 40, so the class width is 20, because that's the width. And what's the height? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares between 0 and 5, so each goes up in 0.5. So this is 5, 4.5, 4. So the frequency of this one is 4, because that's the frequency density, times the class width of 20, so there's 80 girls in that bar. In this one, you can do the exact same thing. So the class width here is 5, and it goes up to 10, so it's just 10 times 5, which is 50. Now, I'm going to give you a little bit of a secret here. In mark schemes, and maybe even in your schools, they teach you a method that's slightly different, but in my opinion, it's a lot worse. Instead, what they do is they take the whole bar, so what they'll do is they'll do 10 times 10 in this case, right? So the whole bar here, and then they'll times it by half, which still gives you 50, right? But the reason why I don't like this is sometimes you're only like a third of the way in a bar, so then you're timesing by 1/3 or something, which is really stupid in my opinion. It just makes it needlessly complicated. So just in case you're wondering, you know, if you've seen it in a different way or something, this way will work every single time. So you don't really need to worry too much about it. The method they show you in mark schemes, you change which fraction it is, and it makes it a bit harder, in my opinion. But in total, it's just going to be 50 plus 80, which is 130. Okay, so our answer back up here, 130. All good? Now here is where things are going to get a lot more fun. Fred uses the results of the survey to compare the percentages of girls and boys who worked 1 hour or more last Friday. 580 girls took part in the survey. Okay. Complete the following statement. Something percentage of girls compared with something percentage of boys worked for 1 hour or more last Friday. Okay. So this is basically just a bigger version of what we've just done. Okay. We need to work out how many girls did more than 1 hour, and then how many boys did more than 1 hour. Okay, let's get to it. And also we need to know the total, right? So in total we have 580 girls. So we also need to work out the total number of boys. Okay, so maybe we should do that first. So total boys equals. So let's have a look, see. How would we work out the total number of boys? Well, all we would do is we work out the frequency of every single bar and add it together. And that's it. So, let's get to it. You can see why it's 6 marks, hopefully. So I think it's still going in 0.5. So 0.51, 1.52. So that would be 2 times 20, which is 40. That's 15, and the width is 10. So it's 10 times 15. That is 19, so, and the width is 10, so 10 times 19 is 190. This one over here is 10 times 10. If you can't see where I get any of these numbers, please let me know. Okay, so again, the class width here is 10 and the frequency density is 10. Here, the class width is 70 to 100, so that's 30. And the height is just 1. I was about to write equals 1 there. So in total, all we're doing is adding all of those numbers up. So 150 plus 40 plus 190 plus 100 plus 30. So let's quickly use a calculator. Let's see how, because I really don't want to do this in my head. So 150 plus 40 plus 190 plus 100 plus 30 gives me 510. So it's 510 boys that take part. Okay, good. The total number of boys is 510. Okay. Now we want to work out the number of boys who worked 1 hour or more. So this should be quite easy because we've actually already done the legwork for this. If we look at 1 hour or more, that's 60 minutes or above. 60 minutes or above. So that's just, we're doing 100 plus 30, so 130 boys. So then the percentage would just be 130 over 510 times 100. So 130 divided by 510 times by 100 gives me 24.5%. Oh, I was wondering who that was. Okay. For 21B, can you just prove it by substituting it? What do you mean by substituting? Like, as in just putting different percentages or something? God, my throat is dying. In the meantime, let's do... Oh, whoops, my bad. Yeah, you could substitute it and say it won't have much effort, but it's only 1 mark. That's the only thing, right? It's not, it's not that much. Yeah, so the number of girls. So again, we're doing the same thing. We've got 15 times 10, 150. And then we've got 30 times, so that would be 1 to 2.5. Okay, that's interesting. Oh, perfect. 1 step closer to PewDiePie. 60, and then 75? Yeah. Okay. So that would be 225 in total. So the percentage of, so the number of girls was 225. And the percentage would then be 225 over 580 times 100. Man, I love 6-mark questions, especially with stats. They're so fun. I hope I haven't bored everyone else to tears. So 38.8%. And yeah, there we are. Perfect. 6-marker. I think that's actually a pretty decent one. No algebra. Algebra's fun, right? Okay. Whew. Okay. Here's another mean question. So since we're running kind of low on time, who wants me to go through the mean? Is that okay? It's again got a bit of democracy going on. Don't forget to vote. No? Okay. Skip that one. Now, okay. Part 2, though, in which group does the median lie, this is actually something we should go through. Because I haven't told you how to work out the median of, again, grouped continuous data. Okay? So the way you'd work out the median normally is you put the data in order and then you find the middle number. Either by crossing off both sides or, dividing by 2 or something like that. With grouped data, well, the data is actually already in order, right? Okay, well done, smarty pants. Okay. So yeah, the data's already in order. So that's all good. Right? So all we need to do is find the middle. So the way we do that is, as Evie said, we take the number of pieces of data and divide it by 2. So the number of data would just be 5 plus 20 plus 23 plus 52 over 2. Okay, so again, it's not a mental math test, so let's just work it out. So 100, so it'd be 50. We're looking for the 50th piece of data. Okay. When do you need to add 1 to n? Good question. So you add 1 to n if it's going to be like an odd, if it's an odd number, right? Because if it was, let's say it was like n over 2, but instead of 100, I got 101 over 2. I can't divide that by 2. So instead, I add 1 to it. I'm just looking for the 102 over 2. So the 51st value instead. So if it's an odd number, you just add 1 to it. It's a bit of a cheat, to be honest, but, Can I go over proof? I can do a lesson on proofs. I believe we had a lesson on proofs a while back. No, we didn't. Interesting. I thought we had a lesson on proofs. That might have to wait until next week because we haven't got much time left. But, okay, we'll go over proofs. I can't believe I didn't do proofs. I could have swore I did. All right. Now, how do we find the 50th? That's what I was thinking, but apparently I changed the name of it. Huh. Okay, fair enough. Yeah, that's what I was thinking. Okay, yeah. Anyways. So what we do is, up to this point, we've got 5 values, right? Oh, that's black. Up to the next point, can you see we've got 25 values in total, right? So there are 5 values up to here. There's 25 up to here. The next one, there's up to 48 values. Does that make sense? So if anyone's unsure, let me know. So I had some year 11s today at school, and they were a bit unsure about what I meant when I was doing this. Circles on a graph? No. As in working out like the equation of tangents and stuff? Yeah. So equations of tangents. Yeah. I haven't actually gone through that, no. So equations of tangents. We've actually gone through a couple of histograms at the moment, so far. So you can go back in the lesson to have a look at that if you want. There might be another histogram question in a second. Okay. And in the next one, we obviously have like the 100th value, right? So I know that the median must lie in this class. Right? I may have done a question on it, Evie, but I don't think I've done like a whole lesson on it, to be honest. Okay. Does that make sense to everyone? Oh, I need to get some water before I die. All right. Oops. Okay. So the median will be in this one here. Okay, perfect. So 40 to 50. Like, try not harass people. No, they're not hydrating me in prison. Okay. So yeah, hopefully that all is fine. Okay, this would be a good one, yeah. Because you need to know about the different averages and stuff. Okay, we'll go through this one. So in the display of 100 pairs of glasses at, I was about to say Davies Opticians, the mean depth of a lens is exactly the same as Marie's Opticians. So Marie says, considering only the mean depth of a lens, our display is certain to be very similar to the display in Davies Opticians. Okay. Well, again, it tells you it's incorrect, but why? So, the reason is the mean is something called central tendency. So what it tells you is what the middle value is. That's what the mean is, right? What it doesn't tell you is the spread of data. So whenever you're comparing two sets of data, this is what you always have to do. So these are 4-mark questions. They'll say compare these two box plots or these two histograms or these two pieces of data, sets of data. They'll do something like that. You need to measure the central tendency, which is the median isn't the same as the mean, but it measures the same thing as the mean. It tells you what the middle value is. Okay? Yeah, so it tells you what the middle value is, but they're actually going to be two different values normally. Okay? Because there's different ways of measuring the mean. The middle value. You need to compare the spread, which is the range, or the interquartile range, right? And you need to compare something called the middle value or the central tendency, which is the mean, median, or mode. Okay? Do that and you'll always get 4 marks. Hey, Hydrocarbon, how are you? Okay. So the mean, median, and mode all measure the same thing, but they're all probably going to be different. Okay? Which is a bit confusing, I get that. But the reason for that is because they take into account different values. Okay? So Marie is incorrect because the mean doesn't tell you about the spread of data. So two sets of data can have the same mean, but have a wide range of values instead. Okay? So does that make sense? If you ever need to compare two sets of data, you want to compare the spread, which is the range or interquartile range. So it's the range for normal data, it's the interquartile range for box plots. And you want to compare the average, so the mean, median, or mode. They normally give you the marks, yeah. They normally give you the actual marks. In fact, yeah, they do. They give you the marks and the grade, but you don't get the percentage. So you have to work out the percentage. But they always give you marks and grade. They kind of have to. Okay. Whew, my throat is killing me. Ooh, okay, this is really good too. Really good question, because again, it compares the mean, median, and mode. Okay. So Gary measures the depth of a river in 6 places between 2 bridges. So we have 48.8, 55, 34, 75, blah, 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 blah. And Gary decides to write each of the 6 depths correct to the nearest 10 centimetres. And then he says that the median is 70 centimetres. So explain why, give 2 reasons why his method is inaccurate. So the first reason is he didn't use raw data. So what raw data means is, well, what does raw food mean? It means it's unprepared, right? You haven't done anything to it. So raw data means you haven't done anything to it. It's just the measurements. And the next thing, small sample size, always good. So, Lila, it's not. So these are the actual values he got, but before he did the median, he rounded them all. So he would have said, okay, this is 50, that is 60, almost got that wrong, that's 30, that's almost got that wrong, that's 80, that's 90, and that's 100. And then he worked out the median. And how the hell did he get 70? Oh, because he got the middle of two values. Yeah, my bad. Yeah, middle of two values. And as Evie pointed out, something you can always say if they ever ask you to improve the accuracy or why is it not accurate or like what's an improvement is you always say about the sample size. You need to make it bigger. That's it. That's always one of the reasons that you can get it. It's nice and free. So for a circle not centered at 0, 0, okay. What you need to do to find r squared is you move everything that's a number to the right-hand side. That will be r squared. So yeah, the number on the outside is r squared, if that's what you're saying. Okay. Perfect. Oh, okay. So because we're running kind of low on time, I want to take a bit of a detour. And I want to talk about the mean, median, and mode, because what they can ask you is they can ask for your opinion, which is a scary thing to give, right? They can say which average, mean, median, or mode would be best for this data. Or they may say, why is the median, mean, or mode not suitable? Right? So you need to know why or when to use each of these three things, right? So, the mean, its positives is that it takes into account all values, right? Right? And they can also ask you to things like evaluate the mean, median, and mode, right? Now, the negative is that because it takes into account all values, is it's affected by extreme values. So let me give you an example. Right? So if I were to give you an example, let's say we had a set of data, right? And it was 1, 2, 3, 4, 5, and then 1,000, right? If I work out the mean of this data, I'm going to get a number that's around 990, 980. But does that actually tell me what the middle of the data is? Like, does that make sense as it being the middle of the data? Not really, right? So the reason why that's relevant is if you were working out, for example, the average income of someone in the UK, you don't actually use the mean. I don't know how much you watch the news, but they actually use the median. Why? Because there's people like Richard Branson in the UK that earn billions of pounds a year. Exactly. So CEOs and normal employees is a bit tricky, but you'd use the median. Because the CEOs might be earning millions a year, whereas the lowest paying job is probably about 19,000 a year. Right? The mode is a bit of a tricky one because it's not really... So the negative of the mode is that it's not representative, right? Because it's not really representative, right? Like, it just tells you what the most common salary is, not what the middle salary is. So mode isn't really ever used, to be honest. Unless you're doing things like what colour car is most suitable. So the benefit from mode is you can use it for qualitative data. Oh my god, I've spelt this wrong. Qualitative. God. Qualitative data. So for things like colours, right? I can't work out the average colour. I can't work out the mean of a colour or something like that, or even a shoe size, really. You kind of can, but not really. But anything that's qualitative, right? Like, what's the average eye colour in the UK? Right? But yeah, think about it, right? It might be useful to know. Like, what's the average colour car? Like, what's the most common colour car? That's really useful for people like Honda who want to produce cars, right? So you would use the mode because you can't work out the mean or the median for those. Okay, and Evie, I'll get to your question in 1 second. The benefit of the median is that it's not affected by extreme values. So for the data that I gave you at the bottom, you would use the median because it isn't affected by the 1000. By extreme values. But the downside is it doesn't take into account all values. Okay. In fact, do you know what's even more funny is, again, I don't know if you guys watch the news, but for things like, again, we said salaries, like the average income, we use median because there are some people in the country that earn ludicrous amounts of money, right? There's also a bunch of homeless people that earn nothing, right? So that would skew the data. But also housing prices. We hear about housing prices increasing and falling. They don't use the mean. Why? Because there's mega mansions worth £100 million, right? So instead they use the median, so it isn't affected by those huge, enormous houses that celebrities live in, right? Bit disingenuous, but they want to kind of work out what the average person is paying, like people like you and me, not people that have hundreds of millions of pounds. Okay, so for Evie's question, in a question in my mock, he was asking a question about if n squared minus n is always greater than 0, and my teacher said that n had to be an integer, but it didn't specify that in the question. Intriguing. So that is actually really interesting, but it didn't even specify that in the question. It may have been cut off, potentially. To be fair, it doesn't... Oh, it does matter. Yeah, it does matter. So, yeah. Yeah, because if you use 0.1, it would be less than 0. Yeah, because the thing is, if you use 0.1, it would actually be negative, right? Because 0.1 squared is 0.01 minus 0.1 is negative. So I will say that normally in those algebra questions or those proof questions, n is an integer, but I'm willing to bet they accidentally cut off the bit that says n is an integer. Yeah, they should have said, they cut it off definitely, because in exam questions they're very careful, because you could complain. Right? So they do always say n is an integer. That's really crap. Technically, you should have used 1, because then it's not greater than 0, it's equal to 0. As in, that's what the question was aiming for you. Yeah. Negative numbers squared are positive, so if you minus them, you'd get an even more positive number. But the aim of the question, I think, was to use the number 1, because 1 squared is 1, minus 1 would be 0. So it's not greater than 0, it's equal to 0. Okay. A bit dodgy, not going to lie, but that is the way it is. We're technically out of time. The other question asks you to find the average. Do you need to find the... Ooh. That's a bit misleading, but it is normally the mean, yeah. We'll put 100 plus. I mean, yeah, so, okay. So we are kind of out of time now. Next week, we can do proofs, although I'm sure we did it. If not, I have found a bunch of, tricky questions in those practice papers, which might be useful to go through. Some of them kind of threw me a curveball. But yeah. simplifying massive fractions. If you want to simplify a massive fraction that's like numbers, I just keep halving it until I can't anymore, and then like find small numbers. Like I'll do like 10 steps if I have to. You're very welcome for the lesson, Evie. But I hope all of you have a good evening and a good week as well, because I'll see you next week. Like with algebra. Okay, I'll note that down quickly. In fact, I think we did that last week. Yeah, we did algebraic fractions last week. Yeah, you're very welcome, Milo. So yeah, enjoy your week and have a good weekend, and I'll see you next week.